Okay. This is being recorded. And the whole idea I'm hoping is like, I invite anyone to watch and attend, but especially for a recording for teachers or anyone who wants to self-serve and get them self-started. I'm not doing this event with the coolest, most amazing demos you've ever seen, something like what Bernat would do, but more like an introduction to physical computing. And to give you a sense of this types of summer camps or workshops, or I try to volunteer to introduce young people or older people to physical computing, because it's really a stepping stone toward using technology in any field, anywhere, not just engineering types of fields. So just 2 weeks ago, there was a program that in the Bay Area in San Jose that allows younger girls, they were entering high school. And let me just step out here a second. Entering high school to be introduced to engineering. It's called Get Set, for Get Science, Engineering, and Technology. And they come to Santa Clara University. And let me just see if I can start it over. Or I'll just replay it. And you can just see they were doing a clap program. Watch them trying to clap and seeing the results. They were using the Adafruit Circuit Playground. And I overheard them saying, "This is so cool, all right." And this was just one example of, the many things they were introduced to on that. Flip back to that. So that's the kind of engagement you can get from your students.
Go out of their way to make redeeming credit card rewards.
Oh wait,
complicated.
Gosh, hold on.
Discover isn't like that.
I hate
Discover,
YouTube.
you can redeem your rewards
Sometimes.
For cash.
Stop. How it goes on and continues its advertisements. I don't know if you heard that, but it was starting to feed us ads. Okay. Now we're going to get started. My name is Kathy Giori. I volunteer for MicroBlocks. I try to improve our global partnerships. I'm part of this Tech Women program, so I get to engage in relationships with women all over the world through that program. And I participate a lot with the meetings with John Maloney, Bernat, Turgut Gürünci in Turkey, and we try to get ambassadors around the world who translate. The basic agenda is I'm going to give you an intro to physical computing, much like you would introduce students to it, tell you about the awesomeness of MicroBlocks, why it's so useful in exploring physical computing, and then do some hands-on demos and sort of that getting started piece. And then I'm going to do a whole survey and show you a whole bunch of different hardware, because that's another challenge, I think, for teachers and students and just professional hobbyists is what hardware can I use? What does what? And I'll just give you some off-the-cuff sense of what I like. So the way I try to teach physical computing is to try to get people to think about their senses, how you smell and you see and you hear, and then how you actuate and you move and you taste. So there's the first several are sensing, and then moving and talking, that's like actuating. So you think about making robots, and you can think about making people robots, but any kind of robots. And then typically for workshops, like I say, the ones that, if you're doing a short workshop a day or a week or something, the ones that don't involve a lot of wiring, it's just a board and then maybe an add-on kit or an extension, those work really well. But in addition to the microbit, I like to use the Circuit Playground Express because it has LEDs, it has sound, it has just a wealth of sensors to let you hear, feel, see, speak, illuminate, communicate if you get the Bluetooth version or IR. And then you can, with these types of boards, you can get these add-on kits, which again involve maybe some wiring or maybe not. And I can show you what I've done. As I showed the gal I gave a microbit to yesterday, you can just take a paper clip or some sort of wire and stick an old airplane headset into the ground pin and make sure it's seated against the bottom of that stem, and then wrap the top node into pin 0, and you'll just get sound out of your version 1 microbit. So the old version 1s can still be quite useful. And the version 1s work with a lot of kits too. Although the version 2 is better, gotta admit. And then the other thing is just like that, this isn't the only board. There's just a whole bunch of different boards out there with the old Atmel SAMD21 microcontrollers, the ESP8266, ESP32. So all of this M5 stack, stick, Atom, some of the Arduinos with the M0s, Adafruit has a bunch of stuff. And then the Nordic Semiconductor, the NRF 51, 52, the CityLab ED1 board has an ESP32. So there's increasing, and now the new Raspberry Pi Pico, that wasn't out when I wrote this Make article, but now the Raspberry Pi Pico and the Pico boards and the Pico bricks are a pretty great complement. And because this is a Snap conference, I have to do my complimentary, this is just a stepping stone to the Internet of Things, or electronics for good, technology for good in our world. And you can connect ones wirelessly or wired, Bluetooth, Wi-Fi. You can connect any other like 433 megahertz radios, LoRa. There's a whole bunch of ways to communicate these data. And this is Bernat's little Snap program where he just shows that he made two little sprites, one red, one green, sprite 0, sprite costume 0 and 1. And then it's simply a state where if the state of the button is red, then it's a turn off to the onboard LED of an in this case, ESP32. And if it's costume 1, then it's a turn on event for the ESP32 or the ESP8266. I forget which board that was, probably a 66. And that shows how you can communicate over HTTP. You can also use other protocols like MQTT. You can make up your own protocol. So those things are being evolved, and there's never going to be just one solution, but there will be some evolving popular solutions, and we can use Snap as sort of a control interface, and then this as the remote brains that you deploy somewhere. And that introduces kids to IoT, or anyone to IoT. Then for physical computing, like Scratch and Snap, basically MicroBlocks is the only physical computing tool that I know that's completely live, because there's a virtual machine loaded onto the microcontroller. It's a one-time deal. And then you can use the blocks as your visual frame of reference of the logic and the programming on the device. So it's really an excellent tool for physical computing. And the website, if you haven't been there yet, but hopefully many of you have, it's been improved over the last year, microblocks.fun. There's a whole, now if you're in China, you actually inside the Great China Firewall, microblocksfun.cn, you'll find the whole MicroBlocks site in Chinese, because they have difficulty getting things from outside. So we collaborate now with a STEM education company there, and they've actually done a ton of work and donated money to the foundation, because MicroBlocks is an open source nonprofit under the Software Freedom Conservancy. And we use some of those donations to make the website prettier and to buy hardware for our workshops and all good stuff. Then I want to call out Turgut in Turkey, who, when he started working with us closely and getting on our weekly calls, he started volunteering and executing on some amazing accomplishments, which if you go to the user guide or the blocks reference in the wiki, man, oh man, he's done a ton of great work. And so you can explore each little block, what it does, get an example of how to use it. So you really have that dictionary, that reference guide of those blocks available to you. And the blocks palette, there's the standard palette. And then what's critical in physical computing is libraries. Libraries really open up all sorts of different hardware and different components that are added on, and makes it really, again, an easy stepping stone for people to get in there. And they don't have to figure out, how to drive the specific data signal to a Neopixel. They just pull out the Neopixel library, boom, all of that difficult hardware engineering logic has been pre-programmed into the library, and the student simply needs to select the color and turn it on and off and select the brightness, some of those parameters. So here's your basic blocks, and then libraries are really key, strong library support is really key in physical computing. And of course, MicroBlocks is like Snap. You can build your own definition of things. You can build your own libraries quite easily. And you can export them as libraries so that other people can use them. The other thing that's been going on for a while was John Maloney collaborated with some teachers. I collaborated with John and made some activity cards for a specific hardware kits that uses the microbit. So these cards are useful and you can freely copy them, translate the language, print them. We have, there's one little kit you can buy that has them printed already in the kit. So they are really useful for getting started. And now, like I said, if just being a first timer for those that are just watching, I'm going to show you the very basics of getting started. I think in this case, I already have a microbit. Most of my microbits are already running the firmware and so forth, but let's just play around with me. So I've got a triggering actions from button presses. So this has a button A and a button B, and you could press both the buttons. So let's just see if we can drag this over. Now, before I plug this in, you see that this little connection button up here just says connect. When I have the downloaded version, all I have to do is, just see which way this goes. All I have to do is plug in the board. Plug in the board and it will turn green automatically. See that it turned a little green circle around there? If I had the Chrome or Edge browser version, then I would have to click that button and select a port. And if you have a brand new board out of the box, the very first step before that will ever turn green is you have to say update firmware on board. That would be step one for a brand new board. So if anyone has a brand new board, that update firmware on board just simply takes the VM, the virtual machine for MicroBlocks, and loads it onto the board. And anytime you use this board for another project, you use it with MakeCode or Arduino, and you bring it back into the MicroBlocks environment, you'd have to update the firmware on the board. But once you do that, then all of these blocks are live. And so if I just clicked on a block, hence, boom, it already works. So again, to do this little program that we wanted to do, we say, we find the control variables. We say when button A pressed, where's my other lot? Where's my other, might have to, when button A pressed, when button B pressed, and then when A and B. And then when A and B, we're going to do this. And with button A, we're going to display the character A. Right click is a way to duplicate something. And so then you'd say B. And then now I'm going to, for a while here, I'm going to be showing stuff on the microbit. So I'm going to try to change my video input here so that you can see. Let's see which way. See this. Okay. Everyone see my microbit here? Okay, so now if I press button A, I get the letter A. I press button B, I get the letter B. And if I press both buttons, it smiles. So exactly what we wanted it to be is like this. Now, when it says, can you display your name? Well, there's actually a block that really makes that easy. So after we smile, let's say, John, or we'll say, hi, John. Now, if I press, and then I need to click out of the block to make it. And the blocks that I'm doing on this display area on the MicroBlocks IDE environment are actually being pushed to the microcontroller in real time over this serial connection. So now all I have to do is press A and B, and then it does the smiley face, and then it says, hi, John. And then maybe you want to control things like have a little break between that. So I drop that in there and I do a smiley face and wait half a second. You know, you could wait longer. And then it smiles for 2 seconds and then it says, hi, John. Okay, so this is some of the basics. And then what block would you need in order to read a sequence of letters that move across the display? That's just the control block. Now, MicroBlocks has, you know, of course, opening and saving files. So a nice other introductory example I like to do is just to pull in open the blink library. So I say open and blink, and this is just the classic Arduino blink style program. And when it has a when started hat, you just simply click start, and here's my user LED blinking away. And if I wanted to, I think I need to see, there we go. So, and if I wanted to add a variable to change the delay time, I could add a variable called delay. Okay. And I could set that delay when I start to, actually, even rather than setting it once, I could set the delay based on the button. Actually, I could change the delay. Let me do this. I'm going to set the delay to, let's say, 200, which is where it's at. But when I press button A, I could change the delay by 100. And I could duplicate all this. And when I press button B, I could change the delay by minus 100. So now if I start this program, I have my blinking thing. And if I press A repeatedly, and now I don't know what my actual delay is. So what do? After I change it, I'll say that delay. So now if I press button A, I'm already up to 700. And I want to duplicate that block and do the same thing for press button B. You can see this is going down, this is going up. And then over here, if we go back to our example, you can see that, hey, well, maybe I don't want just this little blinky LED. What if I want to do something else? So I could put in the display feature instead. And back to MicroBlocks. So now instead of this set user LED, I could pull in the display and say, you know, set this to a happy face. And let's say duplicate, and then maybe set it to a sad face. And so now you can see that it's going happy, sad really fast. And I can press A button and slow that down significantly.
Kathy, I think you forgot one thing.
What did I forget?
You still have the wait.
Oh, I never changed the blinking. Thank you. I need to actually wait delay. No wonder. I didn't notice that when the I didn't notice that before. Okay. So now if I'm down at 300. Now if oops. I need to make it longer. Now it's about a half second. Now it's up to 1 second. Well, that's the beauty of knowing how to debug these things, is you look what happens and you look what's on the screen, and you figure out the difference between the two. And it helps people explore. And then if you have a problem, you explain it to somebody else and they get you going. And so your display could also be a little jumping jack person. It could be anything you want. Now I'm going to jump into sound and colorful LEDs. And so for this example, I'm going to just pull this and plug in one of these. And so for this sound, this is an example of pulling in a library. So let's just say new. And when I say new, it actually looks at the board and it says, what kind of board am I? Board type circuit playground. It already knows that from the virtual machine already loaded. And then it preloads the basic sensors library, the circuit playground library, and the Neopixel library and the tone library, because it knows it already has all these things in there. So in addition to, I didn't actually have to click, I could press plus and click and find out about the tone library. In this case, I'm going to actually add the ringtone library because that's a fun one too. But for the purpose of the tone, you just simply click on the play note C, and I don't know if Zoom tries to reduce that sound, but that song or that note is the same as MIDI key 60, and MIDI key 60 is the same as frequency 261. But you can do different things with these different types of playing sounds. And if you have an external sound, you have to attach the buzzer to whatever pin that piezo is attached to. So in this case, you can try all of those notes, and then we're going to continue on and make some music. Like if you had an external one, you would attach the pin. Otherwise, the main way to play notes is just to set a beat and then repeat and do a bunch of things like this. So I think, rather than create that whole thing, let's see if I have some music I can open. I can open existing music. I think I have some examples. Star Wars. Although the name of this project will give it away. But here I have a beat and I have these notes to match my project, and then I press start. Actually, it will do that anyway. So you can see you use repeats and notes and beats, distances, and you can play a regular tone. And as I said before, the ringtone library was on the old feature phones. Nokia had something called a ringtone text transfer language. And one day Bernat was showing us how he wanted to reduce how cumbersome it was to play songs note by note. And then I don't know who came up with the idea. I think it was Bernat. He said, oh, wasn't there that old ringtone text transfer language library? And so sure enough, he put that together. And now instead of playing all of these notes, these little, you can look it up on Wikipedia, the sharps and flats and the note name and the length of it and so forth can all be defined with ringtones. And I'm going to play Pac-Man. And then you could have Pac-Man. Sometimes I play Pac-Man on a microbit and then have a little Pac-Man animation on the screen as it's going by. So those are notes. And then when would you want to not use the notes of a keyboard, instead use something else, is for example, you could do a sound effect. And so a sound effect would be for I in, let's say, 50. I need a little bit of math. MIDI keys start at about 50. So let's do I plus 50 for 3 milliseconds, and then have a little bit of a delay, but a very short delay, like, actually, yeah, I'm not sure if I need a delay. Did I do a delay? No, I didn't even use a delay. So cool sound effects here. Let's just even skip the delay. You could add a delay if you want a little tick, tick, tick sound to it, but let's see how this goes. And that's a really fast one if I want to slow it down. And then if you want it to be ticky, you could add like a a little weight. So I don't know if you can hear those, but
Yeah.
kids like to have fun with these cool sound effects. And then Neopixels, you can either extend Neopixels off of regular microcontrollers, or in the case of this nice little circuit playground, I simply open the Neopixel library and voila, I could actually just set all Neopixels to green. I could then, set every other one, let's say, to red, and do something very Christmassy. Now they're every other one. And now if it is Christmas time, then maybe I want to wait for half a second, or maybe less, like 300 milliseconds. And actually, first I want to set them. So let's do a when button B pressed. Since we're already using A, when button B pressed, we're going to set all the Neopixels. And then we're just going to forever rotate those Neopixels by 1. So the Neopixel has this great rotate pixels by 1. And now when I press button B, it's going to animate them. So they're going to, whoops, I got this in the wrong place. Extract block. There we go. Now they're rotating around, and I could make that a little slower. Now you have your little animation, or you could just set one Neopixel. So we could set just the first one to red, or to green, or to, let's say, pink, purple. And now when I press button B, oops, and I never cleared the other one. So now I just have a purple one running around here. But I could just clear the Neopixels and then press B again. Oops. And now I have just the purple one running around. So that's fun with Neopixels. Now we're going to, and as I said, you can, if you have strips, you have to know which pin you attach them to. You can rotate, you can set them by color as well. Instead of the color picker shows you how much red, how much green, how much blue, and then you can set those colors and you'll get some color out of it. So you can define those variables RGB. There's also a hue saturation value, or HSV, or something like that you can set colors to. And then the fun thing I just showed is rotating the Neopixel by 1. And then you could do things like press button A to set a random color. That's also very fun.
Kathy,
And then just
ask a
like
quick question?
sound effects, you can do light effects too. So just quickly show this as an example where there's 255 values in a color. So if we want to set, let's see, for I in 255, let's say, instead of, we could do this sound, we could do the sound and the light together, for example, and then we would set all so let's set all Neopixels to color, and we'll do, let's see, we could actually do, let's see, no, we do want this. If we want it to fade out, then we want to actually do minus, not plus. So we want to do I 255 minus I. And then we want to set, oops, this is the wrong one. I want to set that one there. Let's just extract this MIDI key thing for now. Delete block. And now we have our sound, we have our light effect of red, and then it fades out. And you could do that, you know, if you didn't want red, you could do blue, or you could do any combination of different colors. And you can have some colors fade in and some colors fade out just by knowing how to do loops and blocks. And then fade in would be adding instead of subtracting. And then, as I just mentioned, you could animate sound and light together by using the delay of the sound to match some color. So if I press a button and set all the colors something, and then, and you could, or you could even, whoops, I didn't mean to do that. I meant to do this. So let's just, when button B is pressed, instead of set one neopixel, we'll just set all of them to a color. And then we'll play. And what was it? B and G that we need. So we're going to set B and then G. And we'll just duplicate these two blocks. And we'll set a different color, orange, okay. And we'll set that to G. And now if I press button B, I should get my doorbell. And then you could have a wait here and a clear the neopixels, for example. So simple sound and color going together. Now the other nice thing about all of these microcontrollers is they're basic sensors. And you can play around and explore the basic sensors just by looking at a few different areas. Let me just do new for a moment so we can get rid of all our stuff here. Okay, so on the input, you can actually see what the state of button A, I don't know if you can see that, the state of button A as I press. If I hold down button A, now you see that the switch turns green. There's also a timer. You reset the timer and then click on it. And every time you click on it, it goes up. And then so you could have a timing loop that does something based on time. It tells you the number of milliseconds and microseconds from some point of time, and it keeps going over. Like I said, the board type. So input, it also has the pins. So I think button A is, I think, pin 5. Let's just see. Button A is off. Pin 5 is off. Now button A is on, pin 5. Nope, it's not pin 5. It might be pin 11. Yeah, pin 11. Oh, wait, no. No. All right, well, I don't remember which pin is which, but you can read all these other different, there's analog pins, there's digital pins. It tells you that this board has 11 analog pins. So a lot of these are capacitive touch around the outside. And it has 16 digital pins, and several of them are used up with this onboard sensors and actuators. But the basic sensors also helps you out because there's an accelerometer on board, and tilt X is in this position, and tilt Y is, oops, in this position, and tilt Z is sort of the whole board. If I flip it over, it would be the opposite. And then overall acceleration. So 100 is gravity. And then if I shake it, you get up and down acceleration. The light level is the amount of light. There's a light sensor on here. If I cover my hand, you can see that go down. The temperature 22 degrees Celsius. And then also, oops, I have an old virtual machine that doesn't have magnetic field, is something newly added that you can now use to sort of measure currents and know whether power is flowing through a wire. If you have a coil of wire around it, you can do all sorts of cool things. Their circuit playground also has a speaker and then a slide switch. So in the middle, there's a slide switch here. You can turn it on or off. Right now it's set to the on position. And of course it has, so these basic sensors, well, the cool thing about basic sensors is graphing them. So if you've never done graphing yet, this is one of the coolest things compared to watching Arduino serial streams across the screen. Like one thing you can do is just say, like, let's just say the light level and put that in a forever loop. So you could click that and you can see how the light level goes down or up. And that's kind of like the serial stream of the old way. But even more fun than that is to graph it. And so if I graph that light level here, then you can see the light level, and I'm going to put a 0 at the bottom in this case. If I flash it more toward the window, it might be more, and then you can see how I can now put my hand over and back, and that goes like that. And instead of light level, just clear the graph and put 0 in the middle again. The other fun one to look at is the tilt sensor. Let's just do, you can do X, Y, and Z, but I'm just going to do X and Y. You can do as many variables as you want. And oops, this is the say one. We got to do this one here. Copy this. Okay, so now I'm going to say these variables, and if I turn it in this direction, my red is the X value, and in this direction, my Y is going to be the green. And then acceleration, you'll see, you know, if you just jerk it or something, you could catch any sorts of movements. And there's a lot of good programs that use gesture control for things. And so I could show you an example of that. In fact, I'm going to switch to back to the microbit. And in the case of the microbit, there's some fun little games that I can show you. Actually, just the basic example of balance is very fun. And with balance, you can see, just start that one started. You can see that it's just using the onboard LED. And if I tilt it in one direction, more than like 10, more than the value of 10, then it, and so the goal would be like, how, can you get it to balance so that you could get it to land right in the middle of the board? That could be a little challenge for somebody. And it can be hard. There I go. And I finally got it to land right in the middle, but you can see how it uses that. And so you could create games with gesture. I have this radio texting with gesture. It's very, very fun program. And then there's another one I like to do to show off the motion sensor, and that's called, or maybe it's under art, I think, Magic Glitter. This is another one I really like as a basic example. And it's just, it looks at tilt of X and greater than or less than 50. And in fact, I usually like to put a little absolute value around, around the tilt. And duplicate that, copy that into here. So now if it's, now if I shake it, the more I shake it, or the more I tilt it one way or another way, it will glitter. So you can see how X values it's looking, and you could do that for the total acceleration. you can count all sorts of things, but these are really fun. So let's move on from the basic sensors. We did some graphing and we did these examples. You've seen these palettes. And the other cool thing that's not obvious from this board is basic radio communications. So that's yet another library. And then you really have to have two of these to show the example, but a really fun example, maybe we can do that. One example is we could do send a radio string or a number or a string equals value pair, and then all you have to do is receive the message on the other one. So let's just do this really quickly. So I wasn't watching the chat, but somebody says there's a participant with a question. The sound examples are done in the microbit V2. Well, the microbit V2 or in, let's see, let me show you a case. The microbit V1 has something like the microbit has a little sound thing off the back, or you can extend through other things. And the Calliope Mini has sound on board. So yeah, with the V1, you have to have an external sound. With the V2, which I have around here, this is the V2, and it has the sound right on the back. And it has a microphone. You can do some really fun stuff with that. But again, going to the radio, let's just do one very simple string. So let's just go new. Yes. And you would load the radio library. And it's a very simple thing. So let's say, let's send the string hello when I press button A. And then we could put this also in receive mode. So then we want to know when a message was received. You put it in one of these when hat blocks, when message received. Let's scroll the text of the last string. So if we just want to send strings and get the values, so this, in this case, and then just so we know that we could just see LED display plot 3.3 when we know that we've pressed the button and sent this message. And then if we receive something, it will wipe away this little dot and scroll some text. So this now is loaded onto the board, and I could just test it. I push, it sent a radio message out of hello, but there's nothing on to receive it. So this one now we unplug and we plug in the clue, which is kind of like a microbit. It's an Adafruit board, but it's a little different. But you can use this TFT display. It has inboard sound and stuff. You can use this TFT display using the LED display library. So this will actually still work if I turn on this same example and I press A, it'll turn on that little button. Now this one, we want to receive that message. We need to add a battery. Battery really quick. You can use the little battery packs that come with some of these, or I have this little LiPo battery. Let's see. So again, I didn't do anything special. I just unplugged the microbit from the board. Now I have this battery attached. So now this one, unless the battery's dead, I might need to get a live battery. Let's see if this one has some juice. You should see at least a little power light come on. Let's see. Oh, it is on. Okay. So I pressed button A on this one, and I got hello on this one. Now when I press button A on this one, which is programmed the exact same program, I see hello on that one. And a really cool project written by yours truly, one of my favorites, is the radio texting. So if you go by board, microbit Calliope, and you do radio texting, and you open that, what it does is it uses the onboard accelerometer and tilting to receive the message. So this one now is ready to be used, and you can push this button and you rotate through messages, and I can say, you know, B, and I press a button every time I get to a letter that I like. Oops, I just hit the reset button, sorry. There's a reset button on the back of this, so. Oh, I think it's in, let me just power cycle it. Okay, so it's ready. Start. Go this way, B, and then I want to add another language. BH, let's just say. And that's our message. You could create a whole long string of things, but now this one we're going to switch around and give the battery to the clue, and then program this one with the same exact radio texting one. Plug this one over here. And now this one, now they're both in the ready state. Actually, this message that I had created over here is now gone. So this one now, let's just say A plus B plus C. And when I want to send a message, see if we can see them both in here or not. When you want to send a message, oops, if you shake them, it goes back to before. So I need to be more careful. D, E, and let's see, F. And then when I want to send it, I push both buttons, and this one now should blink, and it blinks and it shows 3 flashes, and then it scrolls the message D, E, F. And then if this one wanted to send some, you know, a 9 or an 8, and then I send it, then this one now has the blinky light, and I flip it over, and it does 3 flashes, and then it shows the message. And this one, the check is just that it's been sent. So that's a really fun example program for using the radio. And then finally, combining like the ability to show information and count things is we have a game called Flashlight Tag, and that will take the light sensor, and you have to point your screen and the light in the same direction, and you have to quickly try to flash somebody else with intense light, because the LED display is the light sensor area, and it will show the counts of 5, 4, 3, 2, 1, and then run out. And then on the clue, because it has a really nice TFT displays, you can actually count like the clapping, things like that. I'm not going to show those examples, but those are fun. This is how the radio texting one worked. Let's see, there are 10 minutes until the end of block A. Okay, so I would like to do some, and then I just want to mention, I'm almost done here with the slides. The Bernat's Offspring game is something he did while his second child was, while he was taking care. And he actually wrote this all in MicroBlocks. And so he has this bunny that can jump and fall and deliver carrots to its offspring. So check out GitLab B Rosa's Offspring to play that game. So explore and be creative. Essentially, I want to thank you for following the presentation, and then I will probably run around and show you a few of the kits that I've used for various workshops, and let you ask questions. So bear with me as I unplug things and I escape from this and I this, and I turn back on, let's see, I need to turn back on the video. Okay. Now I'm going to stop sharing. Hold on. I think I stopped sharing. Hold on. All right, so now we're going to see that we have my friends in the house. And then I'm going to walk by all these kits. This is the brand new Pico Bricks board by Robotistan in Turkey, this company, and you can break apart all these sensors and actuators. And then inside the kit, you can build robots, you can do a lot of things. There's a in the works Piper Make is working on this new kit, which also uses the Pico. The ED1 by City Lab has the ESP32. You can put it into a rover kit, or you can extend. There's a lot of pins on the back that you can make lots of things out of it. The Innova Didactic, this is Tony sitting over there. This is one of his creations of a robot that has a battery inside. You can drive these things around. This also has the ESP32 with a board that extends with Arduino shields. So you can do a lot. This is the Steam Bot. I think it's an ESP8266. And it has a nice motor controller board, and you can print these instructions yourself. Example of an M5 stack. This is a retired kit, but this was actually an IoT smart home kit where you could make your own kit with motion sensors, temperature, humidity, relays, distance sensors, door and window actuation sensors. And then you use the MicroBlocks library for the Raspberry Pi, which acts as your gateway for your smart home. Then we have a DF Robot. Microbit McQueen also uses the microbit. There's a whole bunch of microbit radio kits here. And then we have the MicroBlocks activity kit. This is an example of how I said how you can take an old little headset and add sound to a version 1 of the microbit. And this is an example of a project I volunteered for ornaments that we've done in San Jose. So this is just an example of all these types of kits. So I wanted to go back to questions. Does somebody want to ask any questions about MicroBlocks? Let's see if I can turn so I can see you.
Hi, Kathy. Bob Kahn here in Los Angeles. Thank you so much. That was really wonderful.
Good.
I have a question about the sound on either the microbit or the Playground Express or whatever you can recommend. I've worked with the microbit with my students using MicroBlocks last spring, and I'm wondering, is there any way to add, like to record a sound and have that sound play?
Yeah, so you can record the sound on a microbit V2 and have that sound play. And if you look up on Twitter, MicroBlocks, John Maloney actually did that exact example with his workshop this week. So it has a certain, there might even be an example in MicroBlocks. I haven't used it recently, but you can record about 2 seconds. So it's enough to say something, and then you can play it back. When you play it back, it's very quiet. And what we like to do is add an external speaker, like a Bluetooth speaker or just a powered little PC speaker, something like that, where you can alligator clip to the stems. And when you play it back on one of those powered speakers, you can hear it very well.
Wow, okay.
Play it back on the actual speaker on board the board, not so well.
Yes, yes. Okay. Okay, so then I'll look for that. Thank you.
I also want to mention that this t-shirt with MicroBlocks and Turtle Stitch is courtesy of Yadka, you know, famous Snap, Yadka Hugo. And she did this with Turtle Stitch, I believe.
That's awesome.
Thank you, Yadka. This is another example of Snap and MicroBlocks. We love to collaborate with each other. Other questions?
What kinds of things can go wrong when you're updating the firmware, and how do you solve them?
When you're updating firmware, so the tricky part of the firmware is the boards that require you to push a button or to set in reset mode. So the Adafruit boards require you to like double click or triple click on a certain reset button or a little set button in order to download the firmware. And the LEDs turn a certain color, and even the trinkets and the itsy bitsies, they all have a little LED that says, you know, it turns green, that knows you're ready to download the firmware. The new Raspberry Pi Pico, the RP2040, that also has a little reset button thing you have to click to get it in the mode to reset the firmware. I haven't, there's some of the M5 stacks where you have to ground a pin. The old M5 stick, I actually have to ground a reset pin with a little jumper wire in order to set the firmware. Those are the tricky ones I can remember. Other ones.
How about a 503 error? Have you ever seen that? The 503 that comes up? On a microbit, I should say.
On a microbit. No, I've never had a problem with the microbit, actually.
Okay.
Is the microbit able to do other programs like make code or Arduino?
Well, I find if I take that same microbit over to a different computer running MicroBlocks and update the firmware on that other computer, that generally solves it.
Huh. Okay, so it sounds like it's the laptop itself, maybe?
Well, then, I mean, the same laptop does successfully update firmware on other microbits. Sounds like a real obscure thing.
Yeah, send an email to either, you know, kathy.giori@gmail.com or interest@microblocks.fun goes to a core group of us. And what we'd like to do is if you could pinpoint if there's a way to isolate when it happens, when it doesn't happen, whether you're using a downloaded version or the Chrome browser version of MicroBlocks, stuff like that.
Okay, sounds like a plan. Thanks.
That would help us. And then there are some boards that aren't supported within the IDE, but you can use, I use Platform.io, and you can clone the repository of John's, and then you can flash anything that is supported by the Platform.io ini file, and so it shows all the different boards, including some of these discontinued ones. And then you can flash the firmware with that outside of the IDE. Any other questions people have?
Could you just tell me again, Kathy, where am I looking to find this information about the recording a sound and playing it back?
Go to microblocks.fun. In fact, I should have shown you that. The microblocks.fun, and there's two places to look. Is the Learn section, has a lot of different boards, and you can look up the microbit and the V2, and you can look up components like a microphone, and also the wiki has some kits and examples. And if you don't see something you like, send to interest@microblocks.fun. We also just recently set up a Discord channel. So if you want to join our Discord channel, it's just the name is MicroBlocks. Look up MicroBlocks in Discord. Thanks to
great.
Peter in the Netherlands, who set up that Discord channel for us.
Thank you.
Great. Yeah, I hope you all have a good time and try some of these different kits and try some of the different examples. Play. And then the big thing is, you know, introduce others to the world of technology through MicroBlocks, because if people, especially if they say they're afraid of technology, this really opens their eyes. It doesn't have to be that hard. You can make it harder and dig deeper. And I didn't show you some of the cool things like plug share, where basically the board itself carries its program, and you can hand it off to the next person, and they can say open from board, and it pulls the blocks of the code from the board back into the IDE. So you can share your programs just by simply passing your hardware around. And it's a really great tool for exploring engineering, especially with the graphics. Any other questions? Okay, thank you all for attending, and thank you for the Snap team for organizing all this. I greatly appreciate it. It's a great community.